Hey guys, Mr. Middleton here. Today we're going to talk about biconditionals, inverses, and contrapositives. At the end of this video, you should be able to write a biconditional and determine when one can be written, and you should be able to write an inverse and a contrapositive of a conditional and determine their truth values. Okay, so just a little review. Directions for these problems is to identify the hypothesis and conclusion of the conditional, then write the converse and determine the truth value of each. So here is our conditional statement. If two angles have the same measure, then they are congruent. The hypothesis, the part that follows the if, two angles have the same measure. Have same measure. Alright, and then the conclusion, remember, is the part that follows the then, and that is they are congruent. Congruent, we'll write that all out. Typically I'll just write like this. Alright, and now the converse, remember, is when we switch the hypothesis and the conclusion. Typically when you do that, you don't have to keep the words all the way the same. Like, just grammatically, it wouldn't make sense if I say if they are congruent, then two angles have the same measure. I'm going to not refer to they until I identify who that is. So I'm going to say if two angles are congruent, I'm just going to abbreviate angles here, are congruent, comma, then they have the same measure. Alright. Okay, and so now we're looking at the truth value. Remember, truth value just means is it true or false? Okay, we're going to look at the truth value of the statement. And so of the conditional statement, if two angles have the same measure, then they are congruent. That is true. That's what congruent means. Okay, and if two angles are congruent, then they have the same measure. That's also true. Okay, so here we have a situation where both the conditional and its converse are true. A biconditional can be written when both the conditional and converse are true. So this is kind of leading us into talking about biconditionals because now we have that situation. Okay, to write one, you have to take the hypothesis and the conclusion and separate them with the phrase if and only if. If and only if. Okay, symbolically, okay, when we talked about the hypothesis, I'll just write it up here, that was P, then Q. When we talked about the converse, we did that as Q to P. When we talk about a biconditional statement, we write that as P, and we use this thing here with two lines, okay, because it really doesn't matter which order we have it in, both lead to the other. Okay, so we're going to write the biconditional of the statement above, and it goes like this. Two angles have the same measure if and only if and only if, okay, they are congruent. Okay. It says write the biconditional of the following conditional if possible. Okay, so it says if two lines are parallel, then they do not intersect. So, okay, biconditional, remember that means that we have to have its hypothesis, or not hypothesis, its conditional statement and its converse both true. Okay, so that's why this if possible is here. We have to make sure that it follows the requirements to write a biconditional. So let's think first, is this conditional statement true? If two lines are parallel, then they do not intersect. That's true, that's what it means. They have the same slope, they don't touch. Okay. Now we have to think about its converse. Its converse would say, if two lines do not intersect, then they are parallel. And that is not possible. Okay, so we could have, sorry, it's not possible, but we could have two lines that don't intersect that aren't parallel. Remember, skew lines. And so the converse is not true. Converse is not true, and so we can't write the biconditional statement. Biconditionals can only be written when the converse and the conditional are both true. Alright, in the next example, we're going to work backwards. Okay? It says write the conditional statement in converse of the biconditional. Alright, so we have you get an A plus if and only if you get a 98% or above. And so since we have the biconditional, we know that both the converse and the conditional are both going to be true. But now we just have to separate the hypothesis and conclusion and put it into if-then forms. Okay, so I'm going to write the conditional statement. I'll leave the converse to you. I'm going to say, okay, if and only if is just a part of telling us this is a biconditional, and that separates the hypothesis and the conclusion. So I'm going to say, if you get an A plus, then you get a 98 or above. Okay, finish that converse off for me. Okay, so make sure you write the converse based off of that. Remember, that's just flipping the hypothesis and the conclusion. Okay, but do that. So that's writing a converse and a conditional based off of a biconditional there. So now we're going to talk about inverses and contrapositives. These statements are conditional statements with special characteristics. Okay, an inverse statement negates both the hypothesis and the conclusion. Okay, and negates just says the opposite of it. Okay, so if it says, if you go outside, to negate it would say if you don't go outside. Okay, so we're just saying the opposite. Okay, typically we just do that with not. So with number one, the dance was fun. To negate it, we would not say the dance was boring. We would say the dance was not fun. Okay, and as long as it's not fun, it can be anything else, but the negation of it is just saying it's not what you said it was. Okay, so the second one is the figure is not a square. To negate it, we wouldn't say the figure is a circle. We'd say the figure, notice this already has not, so we're not going to say is not a square. We're going to just not include that word. The figure is a square. Okay, we say x is greater than 10. A lot of people will want to say x is less than 10, but we really want to think of it as it's not greater than 10. Okay, not greater than 10 is one way to think about it, but the mathematical way to write it would be that x is less than or equal to 10. Okay, so notice that what we did is we flipped the sign, but we also included the fact that it could be equal to 10. It's just not greater than 10. Okay, so the negation is saying it's not what was originally said. Again, when somebody says it's hot outside, you wouldn't negate it by saying it's cold. You'd negate it by saying it's not hot. Okay, so that's the negation, is adding that not, making it that whatever they said is not true. Okay. Alright. So that's the inverse. Inverse negates both the hypothesis and the conclusion. So it says write the inverse of the conditional, determine the truth value of each. It says if x equals 36, then x equals 6. The inverse would say if x squared does not equal 36, then x does not equal 6. Okay, now when we look at the truth value of the conditional statement, if x equals 36, then x equals 6, that's actually false. Okay, because x could equal negative 6. The truth value of our original statement, if x squared equals 36, then x equals 6, is false. The truth value of our inverse, that is, if x does not equal 36, then x doesn't equal 6. That is true. Because if it's not 36, then it can't be 6. Okay. A contrapositive, the other new conditional statement, it negates and flips the hypothesis and the conclusion. I think of it as the converse of the inverse. Okay. And so now it's asking us to write the contrapositive of the statement above. So the contrapositive, we're going to negate them, but we're also going to flip them. So we're going to say if x does not equal 6, then x squared does not equal 36. And now if you look at this, and as we kind of already explained why our original conditional statement was false, this is false. Okay, because again, x could equal negative 6, and negative 6 squared would be 36. Okay, keeping in line with showing you the symbolic representations of these statements, the inverse is typically symbolically represented as not P, then not Q. Okay, this is the negation symbol. Some people think this helps them remember these a little bit. And the contrapositive would be not Q, then not P. Okay, again, we flip as well as negate there. All right. Now at the bottom it says write a conditional, converse, inverse, and contrapositive from the Venn diagram. Determine the truth values of each. Okay. So the conditional statement is, say, if you're an NFL player, comma, then you are a football player. Okay, again going from specific to general. Alright, what I want you to do is to write converse, inverse, contrapositive of these and bring this in, complete it for tomorrow, and tell me what you notice. Okay. Alright, I will see you. Hopefully now you can understand when you can write a biconditional statement given the truth values of its conditional and converse, and you understand how to write the inverse and contrapositive of a statement as well as looking at its truth values. Alright, see you.